Hi, I am so glad you joined me today. This little video segment has the potential to clear up a lot of common misconceptions in chemistry. So let's take a look at potential energy. I want you to bear in mind that at the level that I'm talking about potential energy in this video is at a very entry level. Okay, very much maybe 10th, 11th grade chemistry. I would have other videos that you might want to look into for a more advanced discussion of potential energy. So in physics, potential energy has to do with the location of an object. Okay, so objects that are high relative to a norm have high potential energy. Okay, now in chemistry, potential energy is due to either attractive and or sometimes together, sometimes a kind of this sweet spot of stability where attractive forces are maximized and repulsive forces are minimized. So potential energy is due to one and or both of these, attraction and repulsion. So the greater that we have, the greater potential that we have to form attractive forces, the higher the potential. I think maybe it would help if we looked at it this way. A gas would have very high potential energy because it doesn't have many attractive nor repulsive forces. So it has a lot of possibilities out there, a lot of potential to form those. Liquids and then solids would then have lower potential energy. So the more we have maximized our attractive forces and minimized the repulsive forces, the lower the potential energy is. Okay. Now, in other videos, I would draw graphs of the potential energy, and you could see that as one thing I want you to see here, that as we decrease the distance between two particles that are oppositely charged, okay, if we had potential energy, we would lower that or make it more negative. So if this was 0, we would be making it more negative, right? Because a positive times a negative is a negative. So as we decrease the distance, the closer they are, the more attraction we have. So the more negative the potential energy, or the lower the potential energy. Okay? When we have charges, as we increase our charges, if we increased our positive or increased our negative charges, that also gives us a lower or more negative potential energy. So it's all a measure of that charge attraction or charge repulsion. Okay, so chemical energy is a potential energy that is ultimately made available when we take that balance of energy from bonds being formed and bonds being broken. It's a balance. Whether energy will be released is a balance of those processes. And this is where the big misconception happens. Energy is released when bonds formed. I like to say freed to form. Energy is released from the system out into surroundings when bonds formed. Energy is required. It is needed to break a bond. A bond is an attractive forces. It takes energy to break attractive forces. If you don't believe me, put two magnets together, very strong magnets together. that are attracted and held close together and try to break that attraction. It's going to take energy. I think where the misconception comes is biologists talk about energy being stored in ATP. Well, when they're looking at the energy that's released when that bond breaks, they're really looking at free energy available to do work. And they're not looking at the energy that is needed at that particular point in the system where a bond is breaking and a bond is forming. Okay? So they're really looking at what we call coupled reactions. So that's where it comes from, is just a different context of the conversation. For chemistry, this is one of the most important things that you need to get into your mind. Energy is released when bonds form, free to form, takes to break. Okay, the overall energy change of a reaction is if we add up all the energy that it takes to break, here, let me do it here, takes to break, and then we add up all the energy that's freed to form, okay, energy that is required is positive. When it's released, it's negative, and that's a good thing. So energy release negatives in chemistry are not always bad things. It's often a good sign, a negative sign is. So if we take the energy that it takes to break and we add the energy that's released when it frees to form, that gives you your energy of your reaction. Okay? So if the energy needed that it takes to break is greater than is free to form, so this number is bigger than this number, you're going to get a positive. If the positives are greater than the negatives, you're going to get a positive energy, and we call that endothermic. Okay? If the energy, whoops, I just said that backwards. Oh, Dina, let's fix this. No, I did it right. Whew. All right. So if the energy that it takes to break, so if takes to break, if the positive is less than the freeze to form, so if the positive is less than the negative, I'm overall going to have a negative or heat released. That's favorable in chemistry. Heat released is favorable. Okay, and that is called exothermic. Let me erase so you can see that a little better. That is called exothermic. So endothermic means energy has to go into the system overall, and that's going to be positive. If it is, get more space here, if the system releases energy, that's negative, and it's called exothermic. So potential energy is the energy that's inherent in the bonding structure. And we can take that energy and ultimately be able to couple it in ways that we can get heat energy, light energy, mechanical energy, or electrical energy as we take this balance of breaking bonds and forming bonds and capturing energy. Okay, thanks a lot. I really appreciate your time.